Every year, people throw out 4.4 billion pounds of washing machines. That is like 200 Eiffel Towers made of metal and plastic. But what if your old washer could snag you $200 from Samsung or LG, and then come back to life in a totally new way? In this video, we are going to show you how shredders rip steel apart in seconds, magnets snatch out copper, and plastic gets transformed into new gadgets. Why are brands willing to pay for your old junk? And how can a single machine either help save the planet or end up poisoning it? The first 30 seconds will spill a secret that is going to change the way you think about trash forever. You do not want to miss it. Lots of big brands and electronic stores have programs where you can trade in your old stuff, or they will haul away your old appliance for free when you purchase a new one. For instance, in the United States, companies like Whirlpool, LG, and Samsung have programs like this. Over in Europe, they have initiatives under the Waste Electrical and Electronic Equipment Directive. The details can be different depending on the company. Some will just haul away your old appliance, while others might give you a discount toward your new purchase. Whirlpool in the United States, for example, might offer anywhere from $50 to $100 off a new appliance if you're trading in an old washing machine. LG and Samsung sometimes run special promotions where they might offer $100 or even $200 back. Over in Europe, some programs might let you get up to a 10% discount on a new appliance. But more often than not, the discounts are not that big. Most companies really look at this as more of an environmental effort, not just a strategy to pull in customers. In a lot of cities, you will find electronic waste collection centers where people can drop off their old washing machines themselves. These centers often team up with local city governments or private recycling companies. In some countries, like Germany, the United Kingdom, and the United States, there are city-run services that will actually come and pick up bulky electronic appliances. For example, in New York City, you can schedule a free pickup through the city's own program called NYC Safe Disposal. There are also some companies that focus specifically on recycling metals. They might actually buy your old washing machine from you, or at least take it off your hands for free. These companies then send the appliances off to be taken apart, where they pull out all the valuable stuff like metal, electronics, and plastic. First things first, the machines get sorted into different groups. Ones that still work, ones that kind of work, and ones that are completely broken. The machines that still work might get fixed up and resold, but the ones that are too far gone head off to be taken apart. The teardown process starts by taking off the outside panels, the door, and the drum. Things like motors, electronic components, wiring, and pumps are separated out because they can often be reused as parts or melted down for their materials. The different types of metal get sorted separately, like stainless steel, aluminum, and copper. Plastic parts are also gathered up and sent off for recycling. This whole process can be done by hand, or it can happen on special automated lines where machines shred the main body and then use things like magnets and air separators to sort out the different materials. These automated recycling lines for washing machines usually involve several steps, and each step is designed to separate out specific types of materials. First, the washing machines are loaded onto a conveyor belt that feeds them into powerful rotating shredders. The blades on these shredders are strong enough to rip through the metal and plastic bodies, breaking them down into pieces roughly 1 to 4 inches across. Once everything is shredded up, the mix of materials moves past magnetic separators. These magnets grab onto any metals that are attracted to magnets, like steel and cast iron, pulling them away from all the other stuff. Next up is something called an eddy current separator. It uses a different kind of magnetic field to actually push away the non-ferrous metals, things like aluminum and copper. Plastics and other lightweight materials get separated out using air separators. Basically, strong blasts of air blow the lighter bits, like plastic flakes, upwards and into collection bins, while the heavier stuff stays put on the conveyor belt. Toward the end of the sorting line, whatever materials are left might go through optical scanners. These scanners can analyze what the pieces are made of and sort them even further, sending them to the right place for more processing or final disposal. So, after all this sorting with air separators and optical scanners, the different materials head off to their own separate processing lines. This is where the plastic, metal, glass, and anything else gets processed so it can be reused or recycled properly. The leftover metal pieces, like the steel parts, are shipped off to metal processing plants. There, they get melted down and eventually used to make brand new products. Remember those magnetic separators? They are super effective at pulling out iron and steel, which then get sent off to be melted down. The plastic parts get shredded into smaller pieces and then usually compressed into dense bales or blocks. These bales can then be shipped to specialized factories where they will be used to make new plastic items, or they might become part of the raw material mix for new appliances or other tech gadgets. If the washing machine had any glass parts, maybe in the door window, that glass gets cleaned really well to remove any gunk, and then it can be melted down to make new glass products. Any leftover materials that cannot really be recycled, maybe certain kinds of rubber or complex mixtures of stuff, usually end up getting sent for final disposal, often meaning they go to specially designed landfills. These kinds of sorting and recycling setups drastically cut down on the amount of waste that just gets dumped in landfills. Plus, they help get valuable raw materials back into the economy so they can be used again. Sometimes, especially for really tricky materials, they have to use more advanced techniques, like thermal decomposition, which uses heat or special chemical treatments. These methods come into play for stuff that is hard to separate just by shredding and sorting mechanically, or for materials that need extra processing to make sure they do not cause pollution or release harmful substances. Good examples are certain plastic components that have other materials embedded in them, like plastic with metal pieces fused inside or attached rubber seals. Materials like these often cannot be sorted easily using the standard methods, so they need special treatment to break them down and separate the different parts. Rubber parts, particularly those made with complex chemical additives, are often tough to recycle effectively because of their complicated structure. For materials like that, processes like thermal decomposition or other chemical methods might be used. The goal is to basically unzip them into simpler building blocks that can potentially be reused or at least disposed of more safely. In situations where the appliance contains hazardous stuff, think mercury in old switches, or maybe some types of batteries or old lighting components, those materials absolutely have to be handled with special procedures. This might involve a chemical process designed to neutralize the dangerous parts, or maybe one that locks them up safely so they can be disposed of without causing harm. Materials like polyurethane or polyester, which you often find used as insulation around wires or in various other parts inside appliances, might also be treated with thermal decomposition. This helps break them down into simpler substances that could potentially be recycled. And then you have situations where washing machines or other electronics contain complex composite materials. Stuff made of several layers of different materials bonded together, like plastic fused with metal layers or reinforced with fibers. These often require very specialized processing to carefully separate the layers so that each material can hopefully be recycled on its own. Overall, the reason for using all these different technologies is to make the whole disposal process as efficient as possible and to minimize the harm done to the environment. Because if these materials are not handled the right way, you could end up with pollution or dangerous chemicals leaking out into the ground or water. Did you know that your old air conditioner could poison the soil, wreck the ozone layer, and even cost you thousands of dollars in fines? Every single year, Americans throw out millions of air conditioners, and each one is a ticking time bomb of toxic chemicals, heavy metals, and dangerous gases. In this video, I'm going to show you how they actually get recycled. Freon, copper, mercury, nothing gets spared. And trust me, this affects all of us. So first things first, why should anyone bother recycling an air conditioner the right way? To answer that, let's break down what's actually inside one of these machines. Air conditioners contain refrigerants. These are chemicals that can do serious damage to the atmosphere. Older units use ones that destroy the ozone layer. Newer ones, they may not harm the ozone, but they still contribute to global warming. The internal boards and compressors are loaded with toxic stuff like lead, mercury, and cadmium. If you just dump an old AC in a landfill, all that junk can leak out into the ground and water. Now, compressors also contain valuable metals like copper, aluminum, and steel. Those can be reused, cutting down the need to mine more raw materials. But here's the kicker. If you try to tear one of these apart without the right safety measures, those toxic materials can leak out, fast. That's why so many countries, including the United States, have strict environmental laws banning improper disposal. And yeah, in some cases, those fines are no joke. In the United States, old air conditioner disposal is regulated on a federal level by the Environmental Protection Agency, plus individual state rules on top of that. Now, we've already touched on how long these machines usually last. So let's dive deeper. Window and portable units typically last from 8 to 10 years. Split systems? They give you a few more. And those big centralized setups, yeah, the ones we mentioned earlier, they'll run for about 15 to 20 years. Keeping filters clean, topping off refrigerants, and doing regular checkups can stretch that lifespan. But in hot areas where ACs run all summer long, they tend to wear out faster. Once your system hits the end of its life, it loses efficiency. Your power bill goes up and repairs become a money pit. That's why most people end up replacing them, which means more units headed for recycling. There are several ways to recycle air conditioners in the US. A bunch of utility companies run take-back programs for old ACs. Some even offer cash, anywhere from $25 to $100, just for handing your unit over. All you gotta do is apply, and a technician comes out to pick it up and handle it properly. Big chains like Best Buy, Home Depot, and Lowe's will take your old AC for recycling too. Some states have dedicated drop-off sites for electronic waste where you can bring in your unit for free or a small fee. In many cities, there are special bulky item collection days. And some towns offer curbside pickup of old appliances, sometimes even for free if you book ahead. Even charities like Habitat for Humanity Restore take working ACs to resell or use in community programs. And a lot of stores have trade-in deals, where you bring your old one in and get a discount on a new model. When we're talking about centralized systems though, you can't just yank one out yourself. You need to call a licensed tech. They'll recover the leftover refrigerant using special equipment, then ship the whole system off for proper disposal. In many states, improper disposal can mean fines, from $100 to $500 on average. But in some cases, it can climb into the thousands. Bottom line, either take your unit to a recycling facility or use one of those special programs. That's the smart move. Once the AC arrives at the facility, the first step is a professional teardown to safely remove hazardous materials and prep everything for recycling. Removing Freon is a whole process that needs special tools designed to safely extract it from the system. The technician hooks up a refrigerant recovery machine to the AC's tubing system. This device uses vacuum pumps and pressure gauges to control the flow. The system gets opened through service valves, giving access to the Freon lines. The vacuum pump slowly pulls the refrigerant out and transfers it into a sealed recovery cylinder. The tech keeps an eye on the gauges to monitor pressure and make sure every last drop is extracted. Depending on the unit size and how much refrigerant is inside, this process can take anywhere from a few minutes to half an hour. During this step, the workers are fully suited up because contact with refrigerants can be harmful. The equipment's built to prevent any leaks. Everything happens in a sealed environment. Once the Freon is removed, it's stored in that sealed tank and later handed off to certified hazardous waste recyclers. With the refrigerant safely gone, the unit moves on to the disassembly phase, which is crucial for proper recycling. The techs set up special workstations at the facility. Before disassembly starts, they review the paperwork and lay out a plan so they know exactly which parts to pull and how to sort them. The AC gets broken down into its core parts: the outer casing, compressor, heat exchanger, fan, electronics, piping, and smaller components. A typical unit has around 20 to 30 different pieces. The compressor alone might weigh between 30 and 50 pounds. Radiators, anywhere from 20 to 40 pounds each. They use both hand tools and machines, like hydraulic lifts and electric grinders, to cut or unbolt the big metal parts. This step takes about 30 minutes to 2 hours per unit, depending on size and complexity. Once everything's apart, the pieces are sorted by material: metal, plastic, and electronics. Around 90% of the metal in an old AC can be recycled. Metal gets cleaned of paint and grease, then sent for smelting and reuse. Plastics go to specialized recycling plants. Electronics that contain dangerous stuff, like lead and cadmium, are sent to e-waste recycling centers. On average, just one unit can provide 5 to 15 pounds of recyclable metal. That's a big deal when it comes to saving raw resources. Many recycling centers handle tens of thousands of air conditioners every year. That keeps a massive amount of toxic waste out of landfills. After the unit's fully disassembled, the next key step is sorting and prepping the materials for reuse. This process helps maximize resource recovery and shrink the environmental impact. After the initial cleaning, materials are sorted by quality standards. Metals get split into categories: aluminum alloys, steel, and copper. For example, copper wiring is often separated because its market value sits around $4 to $5 per pound. Plastic waste is grouped by type. The bundles for recycling usually weigh between 5 and 20 pounds. Electronic components are sorted by type: motherboards, capacitors, batteries. So recyclers know which ones need special handling, especially those containing rare metals. After sorting, all materials are packed up for transport. Metal parts go into containers headed for smelters. A single container can hold anywhere from 500 to 1,000 pounds of metal. Plastic granules are bagged or boxed up, usually in 50 to 100 pound batches, ideal for manufacturing. Electronics are shipped to specialized facilities, where they get broken down even further. Thanks to this whole process, a single air conditioner can yield a surprising amount of reusable material. Recycling and disposing of A to C the right way also saves energy. Smelting recycled metal takes about 60% less energy than making new metal from raw ore. And today, some companies are already rolling out tech to automate disassembly and sorting, making the whole system more efficient and less dependent on human labor. Ever wondered where piles of old newspapers and boxes disappear? Every day, recycling centers process thousands of tons of paper waste, sorting it in seconds and transforming it into fresh sheets. Picture this: massive hangars, conveyor lines as long as a football field, sorting machines equipped with optical sensors, and drying cylinders heated to 260 degrees Fahrenheit. In just 5 to 7 cycles, paper fibers are reborn, becoming packaging, notebooks, or even furniture. Let's dive into the secrets of paper transformation. Think old newspapers or cardboard boxes are just trash? Think again. They have a future. It all starts simply. Paper and cardboard are collected. That includes old magazines, packing boxes, and even crumpled receipts. From there, the sorting begins, dividing materials by type and quality. For instance, cardboard is denser, while office paper is thin and clean. Sorting is a crucial step in giving paper a second life. So, let's break it down, step by step, in vivid detail. First, meet the key players in the process: machines and people. At large recycling centers, automated sorting lines handle the bulk of the work. But human hands are still essential. Operators on conveyor belts carefully check the paper's quality. It's a teamwork scenario where machines do the heavy lifting and people fine-tune the details. Recycling centers often look like giant hangars filled with mountains of raw material. Stacks of old newspapers, cardboard boxes, office documents, and even postcards. Here, conveyors roar and automated sorting systems buzz, processing everything. Here's how it works, step by step. First up, the initial inspection. Once collected, garbage trucks or special vehicles deliver the paper to the sorting center. At this stage, large contaminants like plastic wrappers, fabric scraps, or glossy-coated materials are removed by hand. Next, the automated machines take over, sorting paper by type and quality. Types include cardboard, newspapers, office paper, glossy paper, and packaging. Quality-wise, it's about separating clean paper from dirty, like sheets with grease stains or adhesive residue, which can't be recycled. Optical sensors and air filters play a big role here. Sensors scan the paper, while compressed air streams direct materials into their respective categories. Cardboard goes left, newspapers go right. Even the best machines make mistakes, right? That's where human operators step in to remove leftover foreign objects, like tape, staples, or plastic windows from envelopes. This process moves fast and demands sharp attention. After sorting, the paper is compacted into massive bales for easier transport to factories. Imagine blocks the size of a refrigerator, neatly packed and ready for a new life. Fun fact, old newspapers are easier to recycle than glossy magazines. Why? The glossy coating is harder to remove. Office paper, being high quality, often gets turned into new sheets for printing or even toilet paper. Next comes shredding and cleaning, the phase where old paper becomes the base for new material. Think of it as a paper bath, with powerful machines that not only shred, but also meticulously clean the paper of any impurities. Let's dive into the details. Compressed paper bales go into hydropulpers. Sounds intense, but these are just giant mixers. The paper is soaked in large amounts of warm water to help separate the fibers. Why water? It softens the paper, breaking it down into its cellulose fibers. Special chemicals, safe for the environment, are often added, like soap or alkaline solutions, to remove ink and glue. The hydropulpers kick into action, spinning water and paper at high speeds. The result? The paper breaks down into microscopic fibers, turning into pulp. Yes, that's the term. A gray, wet, slurry-like mass. At this stage, old boxes, newspapers, and letters lose their form and start a new cycle of life. The next step is cleaning the pulp to remove contaminants like plastic, glue, staples, and ink. It starts with screens of varying sizes. The pulp is pushed through under pressure, leaving larger debris like tape, staples, plastic bits, or thread behind. Smaller particles continue downstream. Then come the centrifuges. Remember physics class? In a centrifuge, everything spins, and heavier particles like sand or metal sink to the bottom, while lighter materials like plastic films rise to the top for separate removal. Water and centrifugal force work together, a perfect team. For ink removal, a process called de-inking is used. Foam made from soap and chemicals is added to the pulp. As the mixture spins, bubbles lift the ink to the surface, creating a frothy layer that carries the ink away. This method, called flotation, works like separating oil from water. Only here, it's ink instead of oil. Finally, the pulp is rinsed with clean water to remove any leftover chemicals or impurities, leaving a clean, fibrous mass ready for the next step, forming new paper. Let me know if you'd like further refinement or adjustments to the style. Glue, especially from labels or packaging, can be a real nuisance. During the cleaning process, it forms sticky clumps. To deal with this, special machines called tack removers capture those clumps before they ruin the final material. At this stage, the pulp is clean, light gray, or almost white, ready for the next step, forming new paper or cardboard. Old newspapers and boxes transform into material that can become packaging, napkins, or even part of furniture. Here's something fascinating. Paper can go through this recycling cycle 5 to 7 times before the fibers become too short for further processing. But until then, hooray, the paper's life continues. From the cleaned pulp, new sheets of paper or cardboard are created. The pulp is pressed, dried, and voila, a new product appears, the packaging for your favorite smoothie or a sleek notebook for your ideas. First, the pulp is spread into a thin, watery layer. It's poured onto a massive moving conveyor covered with a fine mesh, a sort of endless cloth that keeps moving. Water starts draining, and the pulp gradually thickens. This is where pressure takes the stage, turning the process into a true display of technical mastery. The first press, called the forming press, provides a gentle squeeze. Rollers press the pulp onto the moving mesh, evening out the thickness. These rollers are set at varying heights and pressures to make the pulp uniform. At this point, the pulp loses about half its water. Simply put, it goes from a watery mass to something resembling damp felt. Not yet paper, but with a clear structure. Next, the sheet moves to the second press, known as the smoothing press. Here, the pressure increases significantly. Heated rollers squeeze out the remaining water, speeding up the drying process. Not only does the paper or cardboard become thinner, but it also gains strength. At this stage, texture can be added. For instance, office paper gets a smooth finish, while packaging cardboard might have a more textured surface. This is achieved using rollers with patterned surfaces. After pressing, the sheet passes through a series of drying cylinders, massive metal drums heated from the inside. These cylinders reach temperatures of 260 degrees Fahrenheit, and the sheet glides over their surface. Moisture evaporates, leaving the paper or cardboard dry and strong. The cylinders press the sheet tightly against their hot surfaces, ensuring even and quick drying. Alongside the heat, hot air blowers are used to prevent uneven drying. After all, the paper needs to be consistently dry across its entire surface. During drying, the thickness of the final product can be controlled. For example, to make thin paper for notebooks or thick cardboard for boxes, adjustments are made to the roller pressure and the number of passes through the drying cylinders. Before the final drying stage, a special coating can be applied to the sheet, for instance, to give it a glossy finish. These coatings might include starch mixtures to strengthen the paper or clay solutions for added shine. The coating is applied in a smooth layer using yet another roller. After drying, the sheet becomes a finished product. But it doesn't end there. It can be rolled into giant reels if it's destined for printing houses or factories. Alternatively, it can be cut into individual sheets like office paper. Here's a cool fact. One of the main goals of this entire process is to preserve the cellulose fiber's properties as much as possible. These fibers give paper its strength and flexibility. In a way, each sheet is the result of a symphony of machines and human ingenuity. Recycled paper becomes the foundation for thousands of new products. In the packaging industry, it's used for delivery boxes, shopping bags, and disposable cups. It can even turn into furniture or decor, creative cardboard chairs, lamps, or even bookshelves. These items are stylish and can last for years. Most commonly, paper is recycled into stationery, notebooks, folders, and even paper pens. Recycled paper is also ideal for creative projects like greeting cards, scrapbooks, or home decorations. It's amazing to think how an ordinary newspaper or box can live a brand new life. Instead of ending up in a landfill, it gets a second chance to become something useful. Ready to explode with curiosity? In this video, we're about to open some top secret doors to the world of fireworks and firecrackers, things you never even knew existed. Stick around, and you'll see how a simple blend of gunpowder turns into the magic behind the brightest blasts. You'll get the lowdown on the wild history behind their creation and the unusual secrets of master pyrotechnicians. This segment will get your heart pounding faster, trust me. Watch till the end, because the best part is still ahead. Stay with us all the way through, and you'll find out something that'll totally flip your perspective. Don't miss out. Firecrackers, they're the more hot-headed guys in this family. Their main trick? It's all about the sound, not the show. Sure, they're simpler in design, but they deliver the same kind of magic. Noise and pure adrenaline. Like fireworks, firecrackers use black powder as their base, but the approach here is a bit more straightforward. The key is nailing the right balance to get a powerful boom without any extra fancy effects. Typically, a firecracker contains a black powder mixture, a casing, and a fuse. We'll get into what's inside later, but for now, let's talk about the casing. It's usually a paper or cardboard cylinder that holds everything together. The material's gotta be strong enough to hold off the blast till the big moment, but not so tough that it creates dangerous shrapnel. The fuse is the most critical part. It sets off the entire explosive process. It could be a thin cotton wick soaked in chemicals or more modern ignition systems. How are firecrackers made? All the ingredients for the black powder mix are measured out with serious precision, then blended to get the perfect consistency. Accuracy is huge here. Just a little extra saltpeter can make the explosion go wild. Too little, and the firecracker won't ignite at all. Paper or cardboard tubes are cut to the needed length, then carefully loaded with the black powder mixture. These casings typically have sealed ends to build up just the right pressure for the explosion. At the top of the firecracker, a small hole is made for the fuse. The fuse is inserted and held in place with glue or a special sealant. The bottom and top edges of the firecracker are sealed tightly, often using glue or heat bonding. This ensures safe storage and transportation. Next, the firecrackers undergo careful testing. Manufacturers check the sound level, ignition speed, and quality of the explosion. Not all firecrackers are created equal. Cheap ones often have uneven filling, weaker sound, and a bigger risk of misfiring. They use lower quality materials, like plain paper instead of sturdier cardboard. High-quality firecracker casings are made from sturdy yet lightweight material. The black powder mixture inside is evenly distributed for a consistent effect. The fuses have a precise burn time to give you enough seconds to back off to a safe distance. Making firecrackers is no joke. Pyrotechnics plants follow strict safety rules. Workers operate in small crews, wear anti-static clothing, and handle only minimal amounts of mixture at any one time to reduce the risk of accidental explosions. Why are firecrackers so loud? This question comes up a lot. The deal is, a firecracker's explosion isn't just a chemical reaction. It's a massive release of energy in a confined space. When the powder burns, it releases hot gases that expand super fast, creating a powerful shockwave. And since the casing is tightly packed, that wave comes with the trademark boom sound we all know. The word firecracker comes from the French pétard, meaning a blast. Like fireworks, firecrackers trace their roots back to China. Initially, they were used to scare off evil spirits, and only later did they become a popular form of entertainment. Today, firecrackers are an essential part of many celebrations and festivals around the globe. But their history shows that even the simplest things can have deep roots and a fascinating evolution. So, the next time you hear that familiar bang, remember just how much skill, history, and technique is packed into each tiny firecracker. When it comes to making fireworks, you also start by mixing gunpowder with other components. If you think of gunpowder as the engine of the firework, then the other materials are the artists who create that explosion of color, light, and shape. To get bright sparks, you need metal powders like aluminum, magnesium, and titanium shavings. For vivid colors, you rely on metal salts such as strontium, barium, copper, and sodium. To boost the energy of the blast, you add ingredients like potassium nitrate, perchlorates, and charcoal. These act as oxidizers and fuels. And to hold it all together, you use binding agents, like water-soluble glues. Each component is first ground into the finest possible powder. Picture shining metal particles dancing in the light as the master prepares them for blending. These powders are so lightweight, it's almost as if they're suspended in midair, like some kind of magical dust. The most important step starts when the ingredients go into a mill filled with ceramic or wooden balls. These balls rotate gently, grinding the mix into a perfectly uniform blend. There's a soft rustle and a light tapping sound, kind of a subtle rhythm, reminding you that a future burst of colors is being born. As for mixing the ingredients by hand, at traditional production sites, this step is done with great care and reverence. Specialists slowly and carefully blend the ingredients with wooden or copper paddles. Why so slow? Because even a single stray spark could set the whole thing off. The mixture looks like a shimmering sand, where each component has its role to play. To avoid accidental explosions, the mixture is often moistened. Water doesn't just make the process safer, it adds a sort of mysterious alchemy, as gunpowder and colorants form tiny granules. The smallest mistake can cause a tragedy. You know what pyrotechnic masters do before they start working? They remove all metal objects, even wedding rings, to prevent sparks. In many labs, cell phones are strictly forbidden, and employees wear anti-static clothing. Even the air matters. Conditions are kept humid enough so that mixes don't dry out and become dangerously volatile. Before packing the mixture into the casing, the masters test how it burns. A small sample is ignited, and everyone holds their breath. Is that the perfect shade of blue? Are the sparks bright enough? It's like a dress rehearsal before the big show. Creating shapes and colors. That's the coolest part of production. Want a heart or a star in the sky? It all depends on how the stars are arranged. These are tiny pellets with a special composition. Where'd those brilliant reds, greens, and blues come from? All thanks to chemical compounds. For instance, barium makes green, strontium makes red, and copper makes blue. Once all the components are prepped, the next crucial step is filling the casing, where the heart of the future firework is born. It's right here that the explosive mix and colorants become a finished product, capable of painting the night sky in every color of the rainbow. The casing is a shell that holds all the fireworks parts together. It's made from special materials that can handle high pressure and heat, yet remain light enough to shoot into the sky. Cylindrical shapes are perfect for forming sharp patterns like rings, chrysanthemums, or peonies, while spherical shells create symmetrical three-dimensional effects, like a glowing orb exploding into hundreds of sparks. The filling process is super important, because the exact placement of components ensures the desired effect. Let's break it down step by step. First, you take cylindrical or spherical shells, usually made of cardboard, plastic, or specially treated paper with fire-resistant properties. Spheres typically come in two halves that will be joined later. It's crucial that the casing is airtight. That guarantees the explosion happens at the right moment with the right intensity. The black powder charge, acting as the main engine, sits at the center. It's responsible for propelling the firework skyward and making sure it explodes properly. Around that charge, the colorants and special effect mixtures are arranged. Each tiny star element is placed by hand or using special machines. These stars are what we call the pellets that burn in the sky. For spherical shells, these stars are placed evenly, so that when it explodes, it forms a perfect sphere of light. In cylindrical shells, charges are often laid in layers or formed into specific patterns, depending on the planned effect. One standard spherical firework can hold about 200 to 300 pellets. Large, multi-layer shells might have over 1,000 of them. To ensure the firework explodes at the right time, a time delay fuse is added. A small tube filled with a slower burning composition. This timer connects to the main charge, providing a delay between the rocket's launch and the burst in the sky. After all elements are in place, they're secured with a special paste or paper spacers. This keeps every component locked in position during the launch. The casing might then be wound tightly with string or glued for extra rigidity. Crafting one large professional-grade firework can take up to 4 hours, considering all the careful assembly and testing. For a massive show with several thousand shells, pyrotechnicians might work for a few months straight. The spherical shape is the classic standard in pyrotechnics, giving an even spread of stars and creating that perfect circular effect. Filling such a shell requires even more skill. Each star is placed by hand around the central charge. It's all on the master's shoulders. How the components are arranged will define how the explosion looks. For example, to create a smiley face in the sky, the pellets are laid out in the shape of a face. When the powder ignites, those pellets spread out just right, forming the intended pattern. Every year, over 200,000 short tons of fireworks are produced worldwide. China is the leader here, accounting for about 90% of the global output. For major holidays, like Independence Day in the United States or New Year's Eve in Sydney, up to 10,000 separate fireworks might be launched in a single night. Such a display can last over 20 minutes and sometimes costs as much as $5 million. Despite the beauty of fireworks, safety stats are pretty alarming. In the United States each year, up to 10,000 injuries are reported due to improper use of pyrotechnics, with about 70% of the injured being young people under 20 years old. There are over 1,200 crocodile farms worldwide. When people hear about crocodile farms, some imagine wild chaos, with hundreds of reptiles crawling over each other. But that's far from reality. It's way more fascinating and technologically advanced. In China, this industry has evolved into a highly organized business that merges science, nature, and human ingenuity. Let's take a closer look at this extraordinary world. China isn't just a country with ancient culinary traditions. It's also a leader in crocodile farming. With over 500 farms raising more than 2 million crocodiles annually, this industry began booming back in the 1980s when demand for crocodile skin and meat skyrocketed. Over the decades, China has become the top producer, even outpacing Thailand. Here's an impressive stat. In Anhui province alone, the heart of the crocodile farming business, up to 2 million crocodiles are raised every year. And here's the surprising part. Every farm adheres to strict standards of sustainability and ethics. Chinese crocodile farms aren't just enclosures filled with predators. They're scientifically designed complexes featuring labs, climate control systems, and even dedicated incubators. A single adult crocodile can fetch up to $2,000 just for its skin. Add the meat, and the profit can exceed $4,000 per crocodile. The harvest starts with collecting eggs. In the wild, females lay them in sandy nests and leave them unguarded. But on farms, it's a completely different story. Workers collect the eggs immediately after they're laid and transfer them to incubators. The temperature here is regulated down to a degree, 89 degrees Fahrenheit for males and slightly lower for females. Fascinating, right? After 70 to 80 days, the first hatchlings emerge. They're placed in specialized nurseries, where they can grow in comfort under close supervision. How do farm workers know which eggs will hatch males and which will hatch females, you ask? Maybe they scan them like chicken eggs? Or use X-rays? Nope. While farmers might candle eggs early on to check if they're fertilized, similar to what's done with chicken eggs, determining gender this way is impossible. It all boils down to incubator temperature control. Imagine this. On crocodile farms, temperature decides everything, even gender. The sex of a crocodile depends entirely on the egg's incubation temperature. No X-rays or high-tech gadgets needed. If the egg is kept below 86 degrees Fahrenheit, it's likely to hatch a female. At higher temperatures, the odds shift to males. At mid-range temperatures, you get a mix of both. This isn't just a quirk of nature. It's a survival strategy, allowing reptiles to adjust their population balance depending on environmental conditions. In this way, crocodile farmers essentially play God, deciding who gets to hatch. Cool, right? On farms, incubator temperatures are adjusted based on specific needs. If more females are required, for skin or breeding purposes, the temperature is set lower. If males are more valuable, they tend to grow larger and yield more meat. The temperature is raised. Modern farms use computerized monitoring systems, with climate control setups ensuring the perfect conditions. Humidity is also critical and is constantly monitored. Eggs are rotated regularly to prevent embryos from sticking to the shells, ensuring even development. Even with all these precautions, some eggs misbehave and hatch the opposite gender than expected. Nature has its quirks, but overall, this method is highly effective. Comfort is the key word on these farms. Crocodiles are housed in spacious enclosures with water and dry areas. Temperature and humidity are constantly monitored. Imagine each crocodile has its own daily schedule: feeding time, swimming, and basking in the sun. Speaking of feeding, their diet is a science in itself. Crocodiles aren't the type to need 3 square meals a day or smoothies for breakfast. Their feeding and lifestyle are optimized for their natural habits. On farms, feeding becomes an exact science with precise calculations. Crocodiles are fed protein-rich mixes containing fish, chicken, and even vegetables. Everything to ensure rapid growth and good health. In the wild, crocodiles are apex predators, but their farm diet is simpler and cheaper, designed to maximize growth, health, and skin quality. Fish is the most affordable and widely available option, often using small or substandard fish. Poultry industry leftovers are another staple since crocodiles love chicken. Other meats are given in smaller quantities, mainly as a treat for larger individuals. They're also supplemented with protein-rich pellets containing vitamins and minerals. Feeding is organized to be safe and efficient for workers. Crocodiles aren't exactly friendly creatures, so minimizing contact is essential. Workers toss food into their enclosures, either on land or into the water. Modern farms often use automated feeding devices. Younger crocodiles are fed more frequently, every few days, while adults eat about once a week or even less. Interestingly, overeating is a problem for crocodiles too. Overfeeding can make them lethargic and less active, which negatively affects their skin and health. And damaged skin is a no-go. It takes the hide of one young crocodile, about 5 feet long, to make a single crocodile leather bag. So what do crocodiles do most of the time? If you think they're busy being productive, sorry, but no. They spend most of their day just lying around. They sleep and rest for 16 to 20 hours a day, basking in the sun. In the wild, this helps regulate their body temperature. Farms recreate conditions that mimic their natural environment. Crocodiles aren't very active unless they're hungry or threatened. Most of the time, they either float still in the water or shift positions occasionally. In large enclosures, artificial ponds and resting areas let them choose their comfort zones. Surprisingly, they often lie together, like giant sleepy cats, albeit very toothy ones. No balls or toys for these reptiles, as you might guess. Their main entertainment is waiting for food. Some farmers even have a tradition of feeding them from boats to stir them up and make them work a bit for their meal. Crocodiles are all about minimalism. Eat, sleep, repeat. Once, on a farm in Anhui, the crocodiles blocked an exit door for the staff by all lying near it simultaneously. The situation was resolved only by luring them away with fresh fish. One of the world's largest farms, located in Guangzhou, raises about 100,000 crocodiles at any given time. Now, the most interesting part. How are crocodiles turned into valuable products? All farm operations are conducted humanely, under strict veterinary supervision. The reptiles are first sedated to avoid stress. Then, the process follows well-established standards designed to minimize waste. From a single crocodile, up to 75 pounds of high-quality meat can be harvested. It's commonly used in soups and steaks. Their skin, however, is the true treasure in the fashion industry. Crocodile meat is considered a delicacy, high in protein, low in fat, and perfect for a healthy diet. And crocodile leather has always been a symbol of luxury. Depending on the species, it takes 2 to 4 years for a crocodile to grow large enough for its meat and skin to be sold. Interestingly, Chinese farmers waste nothing. Even the teeth and bones are used to create souvenirs or traditional medicines. 90% of crocodile leather sold in Europe comes from China. The highest demand for crocodile skin is in Europe, the United States, and Japan, where leather goods can sell for tens of thousands of dollars. While crocodile farming is controversial, China has made significant efforts to ensure ethical practices. Many farms collaborate with international organizations to maintain transparency and conduct research to protect wild populations. Farm conditions are strictly regulated, as low water temperatures can slow crocodile growth, while excessively high temperatures can be fatal. Opening a mid-sized farm with 1,000 crocodiles requires an investment of at least $500,000. As you can see, crocodile farms in China aren't just about breeding reptiles. They're an entire ecosystem blending modern technology, culture, and business. Who would have thought predators could be part of such a delicate process? Every year, the world produces over 420,000 tons of snails. That's more than the weight of 300,000 cars. Imagine these slow creatures being transformed into delicacies worth up to 50 euros per kilogram, or their slime being used in cosmetics priced at up to 300 euros a jar. Snail farming isn't just a business, it's a billion-dollar industry. Want to know all the secrets? Stick around till the end. Picture vast fields where thousands of tiny snails crawl slowly among the greenery. These are snail farms, and they're more than just a thing. They're a serious business. Europe leads the world in snail farming, with most farms located in France, Italy, Spain, and Poland. The main species grown here are the Helix aspersa, or small gray snail, and Helix pomatia, known as the Burgundy snail. The idea of farming snails has ancient roots, dating back to ancient Rome. Think about it. The Romans were both gourmets and innovators. They were the first to cultivate snails on a large scale for food. How did it work? Romans built special snail gardens where they kept snails, feeding them herbs, fruits, and even wine. Yes, you read that right. They literally soaked snails in wine to make them more tender and flavorful. The famous Roman naturalist Pliny the Elder, who lived in the 1st century AD, wrote about snails being a delicacy at noble banquets. He even mentioned a Roman gourmet, Quintus Fulvius Lupinus, who established the first known snail farm in the 1st century BC. After the fall of the Roman Empire, snail farming was somewhat forgotten. But during medieval times, monks revived it. For them, snails were a convenient food option during Lent, as they weren't officially considered meat. Clever monks, huh? By the 19th century, snail farms gained popularity in France and Italy, where modern farming methods were developed. The French were the first to turn snails into a gastronomic brand now known as escargot. In the 20th century, snail consumption increased so much that industrial-scale farms became necessary. Today, we have entire industries, from food to cosmetics, all thanks to this ancient Roman idea. Isn't that fascinating? Every year, over 420,000 tons of snails are farmed globally, with Europe dominating the market. France, for instance, consumes about 30,000 tons of snails annually, half of which are imported. Imagine the scale. Let's start with the snail nursery. Farms begin by collecting snail eggs, those tiny white pearl-like balls. The eggs are carefully selected because the farm's success depends on their quality. To encourage breeding, farms create specific conditions. The air temperature must be around 70 degrees Fahrenheit, with nearly 100% humidity. It's like a paradise for snails. Farmers even use special systems to keep the air moist, ensuring the snail's comfort. The eggs are then moved to incubators, where tiny snails hatch a few weeks later, barely recognizable as the future delicacies. Surprising, isn't it? My friend once had pet snails, and they bred like crazy in any conditions. But here, with all this care, there are no guarantees. Perfection is truly the enemy of good enough. Let's take a closer look at how snails grow. Once they hatch, the snails are moved to open enclosures, special fenced areas on the farm where they can crawl freely. They're fed a mix of grains and vegetables like cabbage, carrots, or even lettuce. Snail care is a science. Farmers regularly check their health, provide plenty of water, and even protect them from natural predators like birds or insects. Fun fact, a snail can drink more water than its body weight. In some countries, snail farms play relaxing music to reduce stress. Snails can take up to 6 months to grow large enough for harvest. Their size and weight depend on the species and farming conditions. Harvesting snails is an art. When snails reach the right size, they are collected, often by hand. Each snail is carefully inspected to ensure it's healthy and high quality. In snail farming, healthy and high quality involves several key factors: physical condition, suitability for consumption, or cosmetic use. A healthy snail actively moves, stretches its body, and responds quickly to stimuli like touch. Sluggish or closed snails might be stressed or sick. Their shells must be intact, free of cracks, spots, or chips, a sign of sufficient calcium in their diet. Healthy snails should also show no signs of parasites, fungal infections, or diseases that could affect their viability. On average, a snail weighs about 1 pound, though the ideal weight varies by species. This is the optimal size for culinary use, Before processing, snails are kept without food for 3 to 5 days to clear their digestive systems, ensuring the product is safe. A snail's diet impacts the quality of its meat, so their meals consist of greens, fruits, and special mixes. High-quality snails have tender, slightly sweet meat. They must be raised without harmful pesticides or fertilizers, as they are highly sensitive to contamination. For cosmetic purposes, snails need to produce a sufficient amount of slime, known as mucin. But more on that later. This requires proper nutrition and farming conditions. Healthy snail slime is transparent, impurity-free, and rich in beneficial components like allantoin, elastin, collagen, and vitamins. Quality snails live for 3 to 5 years, which is crucial for sustainable production. However, on farms, they're usually kept for about 14 months. Modern snail farming emphasizes eco-friendly practices, no soil or water contamination, and an organic approach to feeding. A healthy, high-quality snail grows in ideal conditions, eats a balanced diet, and shows no signs of stress or illness. It's perfect for gourmet dishes or premium cosmetics. Collected snails are washed and sent for further processing. If the farm caters to the restaurant market, the snails are immediately placed in special refrigerators, where they enter a state of dormancy, a natural process allowing them to sleep. Globally, over 420,000 tons of snails are farmed each year, with France, Italy, Spain, and Greece being major producers. Snails move at less than half a pound per second, so to cross a football field, they'd need about 5 hours. But they can endure a 2-hour walk in the rain without a break, the equivalent of a marathon for us. An average farm raises anywhere from 100,000 to 1 million snails. Now, the exciting part. How do these slow creatures become delicacies? First, they're prepped for consumption, washed, cleaned, and boiled. Then, they're marinated, baked, or stuffed with delicious sauces. Did you know French restaurants love serving snails in their shells with a garlic butter sauce? It's their signature move. If food is clear, how did snails end up in cosmetics? It's all about the slime. It contains beneficial substances like allantoin, collagen, and glycolic acid that work wonders on the skin. In ancient Rome, slaves rubbed snail slime on their mistress's skin, believing it healed wounds and rejuvenated. In the 1980s, Chilean farmers raising snails for export noticed their hands became unusually soft, free of cuts or scars. This sparked the idea of using mucin in cosmetics. On specialized farms, snails are kept in comfortable conditions where they produce slime. This slime is harvested without harming the animals and used in creams, masks, and serums. They say this ingredient works miracles, rejuvenating skin and addressing imperfections. The snail slime cosmetics industry is worth $760 million and grows 10% annually. The biggest buyer, South Korea. The slime collection process may seem odd, but it's designed to be cruelty-free. There are 2 methods: manual stimulation and automated systems. In manual stimulation, farmers gently massage the snail's body or spray it with clean water and sea salt. The snail secretes slime as a natural defense mechanism. The collected slime is washed and sent for filtration. For automated systems, large farms use special devices. Snails are placed in containers where they are gently stimulated with water or air streams. The slime flows into a reservoir for collection. Afterward, the snails are washed and returned to their enclosures. They can produce slime again after a few days, ensuring the process doesn't harm them. The collected slime is purified, leaving only the valuable components. The resulting mucin is rich in collagen, elastin, glycoproteins, and other active ingredients. After processing, the slime becomes a raw material for cosmetics or pharmaceuticals. Snail slime is then used in high-end creams and serums that repair skin and treat acne. To produce 33 ounces of quality mucin, About 50,000 snails are needed. The snail market isn't just about food or cosmetics. In the European Union alone, it's a multi-billion euro business. 1 kilogram of snails can cost between 20 and 50 euros, depending on their origin and processing. Cosmetic products made from snail slime sell for 30 to 300 euros per jar. Here we are, standing at the entrance of a massive cornflakes factory. Did you know that around 4 billion pounds of cornflakes are made worldwide every year? Impressive, right? You ready? Let's go. I'll walk you through everything step by step, from the very beginning all the way to how these crunchy, delicious flakes end up on your breakfast table. It all starts in the cornfields. For cornflakes, a specific type of corn is used, yellow dent corn. This variety isn't like the sweet corn we're used to eating boiled or grilled. It's starchier and contains less sugar, making it perfect for processing. The corn is harvested using massive combines that literally slice through the fields, stripping the cobs and separating the kernels. From there, it's sent to the factory. Before transportation, the corn is carefully dried to reduce moisture and preserve its quality during transit. At the factory, the kernels undergo hundreds of tests. They're checked for size, density, moisture levels, and even color. Every detail matters to create perfectly uniform and crispy flakes. And when it comes to cornflakes, the most iconic brand is still Kellogg's, which first introduced them way back in 1894. Cornflakes, like many culinary inventions, were born out of a mix of chance and experimentation. They were created by the Kellogg brothers, John Harvey Kellogg and his younger brother, Will Keith Kellogg, in the late 19th century. John Harvey Kellogg was a doctor and the director of a sanitarium in Battle Creek, Michigan, USA. His sanitarium followed strict principles of healthy living, offering patients a plant-based diet, physical exercise, and even some rather radical treatments, like hydrotherapy. One of John's main goals was to develop healthy and easy-to-digest food for his patients. Will Keith Kellogg, his brother, worked alongside him at the sanitarium, handling administrative tasks and helping bring his ideas to life. In 1894, John and Will were experimenting with different ways to process grains to make them easier to digest. One day, they cooked a batch of wheat dough, but accidentally left it out to dry for too long. By the time they returned, the dough had become overly dry and brittle. Curious, they decided to run it through rollers to see what would happen. To their surprise, the result was thin flakes, which they toasted to make crispy. The patients at the sanitarium loved them. Later, the brothers decided to try experimenting with corn, as it was cheaper, more widely available, and delivered even better results. And just like that, cornflakes were born. After the success of their flakes, Will Keith Kellogg saw massive business potential and wanted to sell them on a larger scale. However, John Harvey Kellogg disagreed. He viewed them solely as dietary food for patients. In 1906, Will founded the Kellogg's Company, which remains the world's largest producer of cornflakes to this day. The production scale has grown so much that Kellogg's now uses over 1.5 billion pounds of corn every year. Cornflakes became a massive hit in the US, especially among women who loved them as a quick and easy breakfast option. The original recipe was simple, just corn, salt, and a little sugar. Today's versions come in dozens of flavors and include all kinds of additional ingredients. Now here we are inside the production floor. Huge silos are filled with corn, which is gradually fed into the first stage, cleaning. Specialized machines remove debris, stones, leftover cobs, and husks. Next, the corn goes through a magnetic separator. You might be wondering, why a magnet? It's to ensure no metal fragments from harvesting or transport make it through. Once the corn is thoroughly cleaned, it's sent to giant tanks filled with hot water. Here, it cooks for several hours at around 212 degrees Fahrenheit. This softens the kernels and allows them to absorb moisture, preparing them for the next stages of processing. After boiling, the corn is moved into machines that separate the germ and the hull from the kernel. The germ, the part of the grain that's packed with oil, is removed so the flakes don't turn out too greasy. Once the kernel is cleaned, it's ready for the next step, roller processing. And here's where things get really exciting. The cleaned corn kernels are poured into specialized steel rollers that, under immense pressure, flatten each kernel into a thin sheet. These rollers spin at incredible speeds, and the entire process happens almost instantly. Watching it in real time feels like magic. Corn literally transforms into flakes right before your eyes. The flattened kernels now resemble thin, golden discs. But hold on, they're not quite the flakes you're used to eating just yet. Now we're getting to the massive ovens. This is where the flakes are dried and toasted at around 482 degrees Fahrenheit. It's here that they develop that perfect crispy texture and beautiful golden color. Imagine the smell in this room. It's like popcorn, but sweeter. At this stage, a touch of sugar, salt, or even honey is added to the flakes, depending on the recipe. For glazed flakes, they're coated with a thin layer of sugar syrup that caramelizes right in the oven. How many crunchy flakes could you eat? Fun fact, there's even a championship for speed-eating cornflakes, and the record stands at 16 ounces in just 1 minute. Crazy, right? Now watch as countless hot, crispy flakes roll off the conveyor belt. But not all of them make it into the boxes, only those that pass quality control. Special machines check their shape, thickness, and even the sound they make when they break. Seriously, that's a real quality measure. Once the flakes are ready, they're cooled and packed into bags. The machines automatically weigh each portion, seal it in foil-lined bags to keep it fresh, and place it into cardboard boxes. It takes about 3.5 ounces of corn to produce 1 box of flakes, but growing that amount of corn requires 5 gallons of water. Here's a fun throwback. In the 1980s, a British company tried selling cornflakes in cans, like soup. But the idea flopped because customers thought it looked too weird. Almost 100% of cornflake boxes are made from recycled cardboard, and the printing is done with soy-based ink. Here we are, standing next to the warehouse filled with ready-to-go products. Just imagine, these boxes of cornflakes are about to head out to every corner of the globe. There'll be breakfast for kids in the United States, snacks for students in Europe, or even a key ingredient in desserts across Asia. Fun fact, cornflakes were actually invented in the United States, but today they're a hit in over 180 countries worldwide. Modern factories take eco-friendliness to the next level. Leftover corn from processing gets repurposed as livestock feed, and the cardboard boxes, they're made from recycled materials. Oh, and here's a surprising twist. In some farming communities, cornflakes are actually used as cattle feed. Farmers discovered that cows love this stuff. Cornflakes have even made it to space. They were included in the diets of American astronauts during NASA missions. Every year, more than 6 billion servings of cornflakes are consumed worldwide. That's enough to feed the entire population of Earth breakfast for 3 weeks straight. And here's something crazy. Listen closely. If you place a magnet near cornflakes, they might actually move toward it. Why? Because cornflakes are fortified with iron, an essential nutrient for human health. Have you tried it yourself? Drop a comment and let us know what happened. Sell 100 million pairs of shoes in a year? What kind of production can pull that off? You won't believe it, but Crocs did just that. Today, we're gonna walk the path of the world's lightest footwear, from a polymer bead to a cult favorite. And from that cult, we'll move on to recycling these shoes. Crocs was founded in 2002, and their products instantly took over the world. The manufacturing process of Crocs is pretty complex. It all starts with the raw materials. They're the key to Crocs' success. The material they're made of is called Crocodile, a patented foam resin that provides lightness, comfort, and durability. It's not just rubber shoes like many people think, but a special closed-cell foam material. Crocodile is a type of ethylene vinyl acetate, a polymer material that boasts water resistance, cushioning properties, and high wear resistance. Polymers for Crocodile are produced from oil or natural gas, which are processed into polyethylene. Large chemical enterprises located in Asia, Europe, and the USA supply this raw material to Crocs factories. The raw material is transported in the form of pellets. They're easily shipped in large containers and stored in dry conditions until production begins. The main Crocs manufacturing factories are located in Asia, Vietnam, China, and Indonesia. These countries have access to affordable labor, large volumes of raw materials, and robust logistics. The name Crocs comes from the word crocodile, because these animals can live both in water and on land, just like these shoes. Now let's head over to the production line, bro. Check out how these guys load the pellets into a special machine where they're heated to high temperatures. It's seriously hot. The melting temperature of the material reaches 400 degrees Fahrenheit. The material melts and becomes liquid, resembling thick cream. The liquid polymer is poured into special molds that shape the shoes. The molds are subjected to high pressure, ensuring all the details are filled tightly. Excess polymer oozes out under pressure from the mold, kinda like creme brulee. If it weren't for the smell in the factory, you'd be tempted to take a bite, right? But it's definitely not something edible. As it cools down, the material expands, creating Croslite's unique closed-cell foam structure. This provides lightness, elasticity and softness, water resistance, and antibacterial properties. The shoes weigh on average only about 5 to 7 ounces. Confess it, who's gonna run off to weigh their Crocs after watching this video? But let's keep going, bro. Shoes made from these amazing pellets don't absorb odors and are easy to clean. But all this happens after they're taken out of the mold. That's when the excess material is trimmed off and the edges are smoothed. Look how quickly and precisely these guys work. The surface is polished to avoid burrs or roughness. It takes less than 5 minutes to produce one pair of Crocs. After trimming the excess material from the mold, the cut edges are treated with grinding machines. This is done to remove sharp edges, burrs, or irregularities left after trimming. First, they use abrasive belts or discs with medium grit, which quickly remove large irregularities. Rotating grinding tools allow the edges to be processed evenly and replicate the shape of the sole and the upper part of the Croc. Then, the workers move on to fine polishing. To ensure the surface is soft and smooth, they use fine grit abrasives like sanding sponges. This stage removes microscopic roughness that could cause discomfort when wearing. For particularly sensitive areas, like the edges of the ventilation holes, they use hand tools, like sanding sponges or polishing pads. Hand polishing guarantees the absence of even the smallest burrs. In the US, the military uses them as shower shoes because they're water resistant and dry quickly. Other elements are added to the finished shoes, namely straps and Jibbitz. The straps for securing are attached separately. They're made from the same material or from more rigid polymers. Rivets are installed on the straps, allowing them to move. What kind of Jibbitz do you have, bro? Jibbitz are decorative accessories that attach to the ventilation holes of Crocs. They allow you to personalize your shoes by adding elements that reflect your individuality, hobbies, or even mood. The idea for decorating Crocs came about in 2005. It was invented by Sherry Shubitsky, a mom who, together with her kids, came up with a way to adorn Crocs with tiny plastic charms. Let's all write in the comments, "Thank you, Sherry." Sherry used regular decorative buttons that her kids attached to the ventilation holes on their Crocs. The idea was so popular among friends and acquaintances that it eventually turned into a full-fledged business. In 2006, the Crocs brand bought the idea for $10 million, adding Jibbitz to their official product lineup. Jibbitz are small decorative elements made from soft plastic or silicone. They have unique shapes and a special fastening mechanism. Jibbitz can be in the form of symbols, emojis, logos, favorite movie characters, animals, plants, inscriptions, and so on. The back of the Jibbitz has a small stem or pin that fits into the ventilation hole of the Crocs. Thanks to the material's elasticity, the Jibbitz easily inserts and holds very securely. First, designers create sketches of future charms. These can be popular symbols, current memes, or seasonal themes. For example, snowmen in winter or sunflowers in summer. After the design is approved, three-dimensional models are created, which are used to form production molds. Liquid plastic or silicone is poured into molds with detailed designs. After cooling, the material solidifies, retaining the shape of the charm. Simultaneously, the back fastening part is formed, ensuring a secure connection with the Crocs. In 2021, a unique Jibbitz was sold at auction for $10,000. It was made of gold and adorned with diamonds. As for coloring and applying patterns, various techniques are used here, as you can see. Color is added at the stage of melting the pellets so that the color is evenly distributed throughout the structure. And to create prints, they use laser engraving or printing techniques. Each pair undergoes quality checks for compliance with shape, color, and absence of defects. If defects are found, such pairs are discarded or sent for recycling. And that's the end of the production cycle. The finished Crocs are packed into boxes and transported by sea containers or by air to warehouses around the world. Crocs are comfortable shoes, but they present an environmental challenge. The Croslite material isn't a traditional plastic. At the same time, the Crocs brand is making efforts to make its products more eco-friendly and to find effective ways to reuse old shoes. The patented foam material doesn't decompose naturally, so if you throw out old Crocs, they can remain in landfills for decades. Croslite doesn't lend itself to standard plastic recycling methods due to its unique chemical structure. Recycling requires special technologies that most waste processing facilities don't have. You get it, bro. They invented a unique, durable material. But now, the problem is what to do with it afterward. In the past, Crocs implemented a program to collect old Crocs. They disinfected, refurbished, and passed them on to people in developing countries. So, we're cluttering up not our own country, but those who don't have a choice. Controversial idea, huh? That's why the program was discontinued, but it inspired the creation of new eco-initiatives. In some Crocs stores, you can leave your old shoes, which are sent for research into reuse or for conversion into energy resources. Today, old Crocs are sometimes used to obtain energy through the process of pyrolysis. Croslite is burned in special furnaces, and the energy obtained is used for heat or electricity production. Admit it, that's a pretty good look. Also, after shredding, old Crocs can serve as the basis for new materials, such as rubber coatings for playgrounds, insulation material, or as construction or decorative elements. The production volume of French fries reaches 4 or even 5,000 tons per day. In the massive factories of the United States, the process of making French fries resembles a coordinated symphony of machinery, engineering expertise, and quality control. Production at facilities like McCain, Lamb Weston, or Simplot involves large-scale operations that make it possible to deliver tons of crispy fries to fast food restaurants, supermarkets, and food service establishments worldwide. Let's take a closer look at how this process works. Here we go. To make a delicious product, you need the best raw materials. Special varieties of potatoes, such as Russet Burbank or Innovator, are used for French fries. These varieties have a high starch content, ensuring the right texture and flavor. Factories receive millions of tons of potatoes from farming operations. A single large factory can process up to 1 million tons of potatoes annually. The potatoes are delivered by trucks that maintain optimal temperatures to prevent spoilage. Each truck typically carries between 20 and 30 tons of raw potatoes. To preserve quality, transportation happens immediately after harvest. At the factory, the truck backs onto a specialized platform that tilts the truck bed, allowing the potatoes to slide into a receiving hopper via gravity. Unloading a single truck takes less than 5 minutes. During peak season, a factory can handle up to 500 trucks per day. As the potatoes are unloaded, they undergo an initial inspection. Magnetic and mechanical separators are used to remove any metal or stone debris that might have been mixed in with the potatoes during harvesting. In the first stage, I observed how potatoes are washed in large automated drums using high-pressure water. A conveyor system evenly distributes the potatoes onto washing and sorting lines. Factories typically have their own wells or are connected to local water supply systems. Before use, the water undergoes multiple purification steps, including mechanical filtration, to eliminate impurities. Most factories recycle up to 90% of their water, significantly reducing costs. Water is delivered to the conveyor washing systems via powerful pumps that generate the necessary pressure for effective cleaning. Spray nozzles evenly distribute water over the potatoes as they move along the conveyor. The potatoes pass through rotating drums, where high-pressure water removes most of the dirt. Some factories use water baths with air bubbles for a gentler cleaning process, ensuring that dirt residues are removed without damaging the potatoes. This process thoroughly cleans the potatoes, removing soil, dirt, stones, and debris. The water used for washing is collected in reservoirs, where it is filtered to remove solid particles. Once purified, the water is recirculated back into the system. This setup saves thousands of gallons every day. To peel potatoes, special mechanical devices are used to leave only the clean, soft flesh. First, the potatoes pass through abrasive drums with walls coated in rough materials. As the drum rotates, the skin is scraped off, and the clean potatoes move along the line. This method is highly effective for large volumes, processing up to 20 tons of potatoes per hour. Next, the potatoes are placed in high-pressure chambers, where steam is introduced at a temperature of about 131 degrees Fahrenheit. Under pressure, the steam penetrates the skin, softening it. Afterward, the temperature difference and a strong airflow separate the skin from the potato. Following this initial cleaning, the potatoes are processed on polishing rollers to achieve a perfectly smooth surface. This step removes any tiny bits of skin or other imperfections. Why? Why didn't I have one of these chambers as a kid? I used to hate peeling potatoes. It could have been so simple, just whoosh, and the skin would be gone. Life is unfair. Next, the potatoes pass through high-speed cutting machines that slice them into the desired size and shape. There are plenty of options: classic fries, thick, home-style cuts, crinkle cuts, or even spirals. Personally, my favorite is the classic fry. What about you? These machines can cut more than 14 pounds of potatoes per hour. Did you know that several countries claim the origins of French fries? However, it was America that truly popularized them, spreading their deliciousness worldwide. The next process is called blanching. This step is critically important for achieving the perfect color, texture, and flavor. Sliced potatoes are immersed in hot water, approximately 86 degrees Fahrenheit, for 1 to 2 minutes. This process removes excess starch, enhances the color, and helps prevent the formation of harmful compounds during frying. After blanching, the potatoes are passed through drying systems that remove excess moisture. As I have been informed, this ensures a uniform texture and crispy crust. First, the potatoes are loaded onto a conveyor. Excess water initially drains naturally through openings in the conveyor. The potatoes are then transported into a drying chamber, where they are exposed to a powerful stream of hot air. The air temperature must not exceed 60 degrees Fahrenheit to avoid damaging the structure of the potatoes. Depending on the size of the slices, for standard thickness French fries, drying takes no more than 30 seconds. At this factory, the dryer can process up to 22,000 pounds of potatoes per hour. Potatoes are fried in vegetable oil, which can be corn oil, canola oil, or sunflower oil. The fryer temperature reaches 176 degrees Fahrenheit. The potatoes are fed into the fryer via a conveyor belt. On a side note, I'll let you in on a secret. My girlfriend seems to take baths at the same hellishly hot temperature as these poor potatoes, worn out by all the processing. Before frying, automated systems inspect the product once more to remove any overly small pieces that might burn. The calibrated potato pieces destined for frying are evenly distributed on the conveyor belt to prevent them from sticking together during the frying process. The potatoes move through the oil on the conveyor, submerging evenly to ensure consistent frying. During frying, the oil is continuously filtered to remove small potato particles and prevent overheating or oxidation. To avoid burns or the formation of bubbles on the surface of the product, the potatoes are gradually lifted out of the hot oil, ensuring a smooth temperature transition. The total immersion time is approximately 1 minute, just enough to create a light, crispy outer layer. After frying, the potatoes pass through tunnels with streams of cold air, which helps preserve the product's freshness and quality. Cooling French fries after frying is a crucial step in the production process, as it prepares the product for subsequent stages, such as freezing or packaging. The entire process is carried out quickly and meticulously. Cooling helps maintain the fries' crispiness and minimizes internal softening. Additionally, it prevents the formation of excess condensation, which could compromise quality during freezing. After frying, the potatoes are loaded onto specialized conveyors equipped with air tunnels. powerful fans circulate cooled air through these tunnels, and their speed is adjustable to avoid damaging the fries. For uniform cooling, the potato pieces are continuously stirred or flipped on the conveyor belt. A single cooling tunnel can process up to 11,000 pounds of potatoes per hour. The potatoes are weighed and automatically packaged into bags of various sizes. One production line can package up to 150 bags per minute. Impressive speed, isn't it? The cooled or frozen fries are transferred onto specialized conveyor belts. Vibrating feeders evenly distribute the pieces along the belt, ensuring precise weighing. The scales analyze the fries in real time and select the optimal combination to achieve the target weight. After weighing, the potatoes move to packaging machines, where the bags are formed. There are generally two types of packaging: soft polyethylene bags for retail sales, and large paper or plastic sacks for restaurants. The machines seal the bags using heat-sealed seams, ensuring airtight packaging that protects the product from oxidation. Some bags are filled with nitrogen to preserve the fries' quality for longer periods. Once sealed, labels are applied to the packages, displaying product information such as weight, ingredients, production date, and expiration date. The finished product is stored in refrigerated warehouses, where a constant temperature of -8 degrees Fahrenheit is maintained. A single package of McDonald's French fries can pass through the entire factory process in under 60 minutes. Annually, more than 11 million tons of French fries are produced worldwide, with the majority manufactured in the United States. This entire process is a marvel of engineering, enabling billions of people to enjoy delicious and high-quality French fries. Behind every Casio watch lies a story that not many people know. Today, you will discover the truth about Tadao Casio, the visionary behind one of the world's most renowned technology brands. From revolutionizing the industry with the first digital watch, to the controversial associations with Al-Qaeda, stemming from the use of Casio watches in terrorist bombings, Casio has left an undeniable mark on history. In the quiet village of Kuretamura in Kochi Prefecture, on November 26, 1917, a boy named Tadao Casio was born. His arrival into the world coincided with a time of great upheaval and change in Japan. From an early age, Tadao's life was shaped by a series of events that not only tested his resilience, but also molded him into one of the country's future technological pioneers. In 1923, when Tadao was just 6 years old, the Great Kanto earthquake devastated Tokyo and Yokohama. This natural disaster forced the Casio family to leave their home in Shikoku and relocate to Tokyo. At the age of 14, young Tadao began working as an apprentice lathe operator to support his family. This early experience sparked his interest in mechanics and innovation. Simultaneously, he continued his education at Waseda Workers' School, excelling academically and graduating from both junior and senior schools in 1923 and 1930, respectively. Tadao's school years in Tokyo were challenging, but he adapted, demonstrating the resilience that would later define him. During this period, the Casio family grew with the arrival of new members who would later play pivotal roles in the brand's history. In 1925, Toshio Casio was born in Kyobashiku, Tokyo, followed by Kazuo Casio in 1929. These brothers, along with Tadao, would eventually join forces to establish one of Japan's most influential technology companies, Casio Computer Company. During the 1930s and 1940s, the world was plunged into the chaos of World War II. Among those affected was Tadao Casio, a young man with a vision that transcended his time and circumstances. Due to health issues, Tadao was unable to serve in the military. However, he contributed to the war effort by manufacturing aviation parts in a workshop attached to the family home. This work was not only a form of service, but also an invaluable lesson in precision and mechanics, skills that would prove crucial in Tadao's future entrepreneurial ventures. In 1942, Toshio Casio graduated from the School of Electrical Engineering, now known as the Tokyo University of Electrocommunications, and joined the Ministry of Communications, where he specialized in research on Morse code transmission. 1943 marked a pivotal year for Tadao Casio. He married Shigi Noguchi. Together, they endured the hardships of war and the challenges of the post-war era, raising 3 daughters and a son in a country rebuilding from devastation. The end of the war did not bring immediate relief. American bombings had destroyed the Casio family's home, halting their manufacturing operations. However, this adversity became a catalyst for Tadao to rethink his future. A symbol of this fresh start was the purchase of a milling machine, which Tadao transported over 200 miles. This machine not only enabled the family to restart their business under the new name Casio Manufacturing, but also became a testament to their entrepreneurial spirit. In 1946, as post-war Japan embarked on a path to recovery, Tadao Casio, along with his father Shigeru and brother Toshio, founded Casio Seisakusho in Mitaka, Tokyo. Their first invention was the Yubiwa pipe, a cigarette holder that allowed users to smoke a cigarette down to the very end without burning their fingers. This simple yet innovative product marked the company's first technological breakthrough. In 1949, a pivotal moment occurred. Toshio saw several imported calculators at the first trade exhibition in Ginza, Tokyo, which inspired the Casio brothers to reinvest their profits into developing their own calculators. By the early 1950s, all 4 Casio brothers were actively involved in the family business. Tadao managed administrative matters, Toshio led research and development, Kazuo was responsible for marketing and sales, and the youngest brother, Yukio, handled production. In 1954, the Casio brothers completed the creation of Japan's first electromechanical calculator. This device featured a 10-key numeric keypad, marking a true breakthrough in calculator design. In 1955, the brothers showcased their revolutionary solenoid-based calculator technology at the Bunchodo Corporation in Tokyo. This innovation made calculators quieter and more efficient, symbolizing a departure from the bulky, noisy designs of the past. However, in 1957, a serious incident occurred. During a demonstration of their calculator in Sapporo, the device had to be disassembled for air transportation, but ended up breaking. As a result, the brothers decided to abandon solenoids and transition to using relays instead. Relays are electrical switches that allow a low-voltage circuit to control a high-voltage circuit without direct contact between them. This change significantly simplified mass production. In June 1957, the company adopted a new name, Casio Computer Company. They launched the Model 14A, the first fully electric compact calculator. This marked a significant milestone in the development of consumer electronics. Operations that previously took around 10 seconds on other devices could now be completed in just 5 or 6 seconds. Additionally, the model featured only 10 numeric keys, serving as a prototype for modern calculators. In 1960, Tadao Casio became the president of the company, succeeding his father, Shigeru. This marked the beginning of a new chapter in the company's history. Casio began exploring new technologies and became a pioneer in manufacturing quartz watches, both digital and analog. In 1965, the company initiated mass production of desktop calculators. By 1967, they had opened an office in Zurich to serve the European market, and later that same year expanded into the United States and Canadian markets. Quite remarkable persistence, wouldn't you agree? A major breakthrough came with the release of the Casio Mini in 1972. This was the first personal calculator model affordable for the average consumer. Within 10 months, 1 million units were sold. In 1974, the company introduced the Casiotron, one of the world's first quartz digital watches with an automatic calendar that accounted for months and leap years. During the 1980s, the company ventured into the music industry, launching electronic keyboard instruments such as the Casiotone 201, which revolutionized the music world. In 1983, the world was introduced to the G-Shock, a durable and long-lasting watch that became a global phenomenon. It was designed by Casio engineer Kikuo Ibe, with the goal of creating an unbreakable watch. The concept of the G-Shock was based on 3 key principles: the ability to withstand a fall from 10 meters, water resistance up to 10 bars, and a 10-year battery life. To this day, G-Shock watches remain the most popular product in Casio's lineup. Athletes, especially divers, swimmers, and climbers, rely on these watches. They endure low temperatures, feature scratch-resistant mineral glass, display moon phases and tidal patterns, synchronize time via radio signals, and operate flawlessly for 5 to 10 years. Additional features include a stopwatch, alarm, timer, backlight, and date display. More than 200 prototypes were developed before the DW5000C model was launched in April 1983. The watch quickly earned a reputation as the toughest in the world. The G-Shock also offered digital watch functions such as a stopwatch, countdown timer, alarm, backlight, and the option to toggle between 12-hour and 24-hour formats. In 1989, Casio released the iconic F91W watch, which became one of the most affordable digital watches in the world. It cost less than $20. The watch featured functions such as a stopwatch, an alarm signal, an automatic calendar, and a backlight. Its battery lasted up to 7 years, and it boasted an accuracy of about 30 seconds per month. However, the F91W also became a subject of controversy. In the 1990s, it was associated with use in terrorist devices due to its durability and affordability. As is often the case, when someone creates a device to improve lives, others find a way to use it against human life. After nearly 3 decades at the helm of the company, Tadao Casio passed leadership to his brother, Toshio. However, he remained an advisor and shared his expertise through various publications. The company continued to grow even after Tadao's passing in 1993, leaving behind a legacy of innovation and accessibility. Have you ever wondered why you can enjoy fresh strawberries even when they're out of season? It's not just luck. It's the result of complex processes and technologies that remain hidden from the consumer's view. Today, I'll take you behind the scenes of modern factories where fruits are frozen, dried, and canned, ensuring you always have access to a healthy snack. Buckle up, it's going to be fascinating. Strawberries intended for freezing are usually harvested at the peak of ripeness, when they're at their sweetest and juiciest. Why strawberries, you ask? Because they're the most popular frozen berry in the United States. The country grows an impressive 1.5 million tons of them each year. The US is one of the world's largest strawberry producers, with California leading the way, accounting for over 90% of the nation's total output. Harvesting typically takes place early in the morning, while the berries are still cool and less prone to damage. On large farms, specialized harvesting machines are often used to carefully cut the strawberries. However, for processing, a significant amount of strawberries are still picked by hand. That's because machines can't always handle delicate fruits without causing damage. Hand-picking is more precise, allowing workers to select only the perfectly ripe berries that are ideal for freezing or further processing. Once harvested, the strawberries are sent to the factory. First, the strawberries are sorted to remove leaves, stems, and any damaged berries. Next, they're placed in specialized washing tanks. The berries are either submerged in large containers of clean water or, more commonly, rinsed with powerful streams of water to wash away dust, dirt, and any residual chemicals. Occasionally, weak solutions, such as those containing hydrogen peroxide or organic acids, are used to help eliminate bacteria and reduce the risk of spoilage. These solutions are completely safe and leave no harmful residue. After the antiseptic treatment, the strawberries are rinsed again with clean water to remove any remaining solution. They are then dried to remove excess moisture, either by using fans or simply by draining off the water. According to statistics, the average American consumes about 7 to 9 pounds of strawberries per year. Personally though, I go through that much in a month. How about you? Freezing is the most critical step, as it determines whether the berries will retain their flavor, texture, and nutritional value. Typically, the method used is flash freezing. Strawberries are laid out in a single layer on conveyor belts and pass through rapid freezing tunnels. These tunnels maintain a temperature of around -104 degrees Fahrenheit or even lower. This process causes the water inside the berries to freeze instantly, forming extremely small ice crystals that do not damage the fruit cells. To ensure each strawberry stays intact and doesn't stick to the others, the conveyor vibrates continuously. This method preserves the strawberry structure and minimizes juice loss during thawing. Compared to slow freezing, which forms larger ice crystals, flash freezing delivers the highest product quality. About 30% of strawberries in the United States are frozen for use in products consumed year-round. This practice is popular for both export and domestic use. A major advantage is that frozen strawberries can be stored for up to 12 months without losing their taste or nutritional benefits. Drying strawberries has become an increasingly popular method of preservation. Dried strawberries are enjoyed as a healthy snack and are often added to oatmeal, yogurt, baked goods, granola, and trail mixes. Another trendy option is strawberry chips, which have a light, crisp texture while retaining their vibrant flavor. Strawberries can be dried whole or sliced into thin pieces, which dry faster and make perfect chips. Sliced strawberries are convenient for quick snacking, while whole berries are better suited for use in recipes. The drying process involves placing the strawberries in specialized chambers, where warm air circulates to gradually evaporate the moisture. This slow drying helps preserve their aroma and flavor. Another method involves freeze drying, where frozen strawberries are placed in a vacuum chamber. Under low pressure, the water in the berries sublimates, turning directly from ice to vapor. This results in lightweight, crispy, freeze-dried strawberries that retain their color, shape, and nearly all their nutrients. Though freeze-drying is one of the most expensive methods, it offers the highest quality. I have to admit, after this journey, I couldn't resist buying a home dehydrator to make my own strawberry chips and more. So, while editing this video, I've got a bowl of crunchy, nutritious dried strawberries right next to me. The perfect healthy snack. They're great for on-the-go munching or packing in kids' lunchboxes. To make strawberry jam, ripe, juicy berries are used to ensure the jam is flavorful and rich. After washing, the green tops and calyxes are removed, with care taken to preserve the shape of the berries. This is done either by hand or with specialized tools to minimize the loss of pulp. In production, the strawberries are processed to achieve the desired consistency. This could range from a light chopping into pieces to a more thorough blending for a smooth, uniform jam. This step is carried out quickly using specialized cutters or presses. The strawberries are then typically mixed with sugar and pectin in large industrial mixers. Pectin is almost always added, as it ensures a stable jam texture and helps control thickness, which is crucial for large-scale production. To balance the acidity, citric acid or natural juice concentrate is also added. The prepared mixture is heated in large cooking kettles with precise temperature and time controls. As the strawberries cook, the mixture gradually thickens and the jam develops its desired texture. The high temperature also helps eliminate any potential microorganisms. Once the jam is ready, it's tested for consistency, color, flavor, and aroma. Automated devices are used at this stage to measure density and sugar levels, ensuring the product meets quality standards. The finished jam is then automatically poured into sterile jars or containers, which are sealed airtight to preserve freshness. The process of making strawberry puree is equally fascinating. The prepared berries are placed in grinders, where they are processed into a liquid state. This is achieved using specialized mills or blenders that quickly break down the fruit into a smooth, uniform texture. The pureed mixture is then passed through special sieves or filters to remove seeds and small bits of skin, ensuring a silky smooth puree if a very fine consistency is desired. This step is crucial for producing a product suitable for baby food, desserts, or yogurts, where a soft texture is important. To extend its shelf life, the strawberry puree undergoes pasteurization, a process in which it is heated to a specific temperature that destroys harmful microorganisms while preserving the fruit's flavor and color. Pasteurization typically takes place in tubular heaters or specialized cooking systems. In some cases, especially when the puree is intended for industrial use, such as in confectionery or for making semi-finished products, it may be frozen. To To produce juice, strawberries are first processed into puree using industrial blenders or mills. This step creates a mass from which juice can be more easily extracted. The strawberry puree is then sent to specialized hydraulic or belt presses, which separate the juice from the pulp. This method ensures maximum juice yield, leaving minimal residue such as skin and seeds. The extracted juice is filtered to remove solid particles, resulting in a smooth, uniform liquid. To extend its shelf life, the strawberry juice undergoes pasteurization, a process that involves rapid heating followed by cooling. The finished juice is then poured into sterile bottles or cartons, sealed tightly, and stored for later use. The same processing principles apply to other fruits and berries. When it comes to nutritional benefits, freezing preserves most vitamins, including vitamin C and antioxidants. Additionally, like fresh berries, frozen strawberries are low in calories, making them an excellent dessert option for athletes and those focused on healthy eating. What's your favorite fruit or berry? Let me know, and maybe my next video will feature it. Do you know how many servings of instant ramen are consumed worldwide each year? Over 100 billion, and in the United States alone, up to 5 billion. In this video, I'll show you how simple dough is transformed into noodles that save students and office workers from hunger in just 3 minutes. We'll talk about the different types of noodles, the production process, and how all those amazing flavors are added. And of course, we'll dive into what it means to get invited out for ramen in various Asian countries. The production of instant ramen, yes, that iconic quick cooking noodle, is a highly technological process involving specialized machines for mixing, shaping the noodles, quick cooking, and packaging. I've seen how noodles begin their journey, starting with dough preparation. The base for these noodles consists of flour, water, salt, and an alkaline solution called kansui, which gives ramen its signature springy texture and yellowish hue. The type of flour used in instant ramen is crucial. High gluten flour, typically made from hard wheat, is the standard. The high gluten content ensures the dough is elastic and strong, which is essential for the noodle's texture. Sometimes, the flour is further treated or blended with small amounts of potato or cornstarch to enhance the noodle's elasticity and firmness after cooking. It's pure culinary magic. By the way, outside of Asia, instant ramen is one of the most popular ready-to-eat foods in the world, especially among students and travelers. The ingredient delivery process is typically automated. Flour, water, salt, and kansui are fed into the mixer from large containers through specialized dispensing systems. This setup allows for precise control over the proportions of each ingredient in every batch of dough. Sensors are commonly used to measure the exact quantities, and once everything is loaded, the machine automatically starts the mixing process. I was amazed at how powerful the mixing blades are in these machines. These blades ensure intense and uniform mixing of the dough to prevent lumps and achieve the ideal texture. They move in different directions and at varying speeds, which helps to evenly hydrate the dough and enhance its elasticity, especially with the addition of kansui, which gives the noodles their distinct structure. The first instant ramen was invented in Japan in 1958, and at the time, it was considered a luxury item rather than a quick meal option. After mixing, the dough is automatically transferred to the resting section, a crucial step where the gluten develops to the desired level, giving the dough a uniform texture. The resting machine is equipped with several layers of conveyor belts stacked one above the other. The dough is placed on the top conveyor, which moves slowly, allowing the dough to rest while gradually advancing. The conveyors operate at a slow pace to provide the dough with the necessary resting time. As the dough travels through all the levels of the machine, it rests for 10 to 30 minutes, depending on the recipe and the type of noodle being produced. This resting period allows the gluten to stabilize, making the dough more elastic, resilient, and better able to hold its shape after cutting. The machine maintains optimal humidity and temperature to prevent the dough from drying out or losing its essential qualities. Some machines are even equipped with specialized steam humidifiers to ensure the dough stays properly hydrated throughout the process. Once the dough has completed its resting phase, it is automatically fed out of the machine and into the rolling section for noodle shaping. The dough enters a machine equipped with a series of rolling rollers. These rollers gradually reduce the dough's thickness with each pass until it becomes thin, typically less than an inch thick. Each pair of rollers rotates at a specific speed to ensure uniform thickness without overstretching the dough. Modern factories, thanks to automation, can produce up to 1 million servings of instant ramen per day, making the process both highly efficient and consistent. Once the dough reaches the desired thickness, it moves on to the cutting stage. The machine is equipped with a set of sharp blades that slice the dough into strips of a specific width. The width varies depending on the type of noodle, ranging from thin to wide. These freshly cut strips automatically form long noodles, ready for the next step in the process. What fascinated me the most was how they make the ramen wavy. I finally saw that the shaping machines are equipped with special vibrating mechanisms or profiled rollers. During the cutting process, these mechanisms vibrate, causing the noodles to curl into small waves. Amazing, right? The entire machine vibrates, and the noodles naturally take on that classic wavy shape. Truly incredible. Wavy noodles not only hold their shape better in packaging, but also absorb broth more quickly once hot water is added. It's a beautiful process. It's no wonder Japan has museums dedicated to the history of instant ramen, where visitors can learn about its evolution and even create their own unique serving. In the final stage, the shaping machine divides the noodles into individual portions. Special blades cut the noodle strips to a specific length, ensuring they fit neatly into the packaging. The portioned and shaped noodle blocks are then sent onto a conveyor belt for the next step, either pre-cooking or drying. This automated process helps maintain the integrity and uniformity of each portion. Defect control at this stage is also fully automated. I was fascinated to learn that the machines are equipped with sensors and computer systems to monitor quality, ensuring consistent thickness, width, and length of each noodle strip, while also detecting potential defects. Next, the noodles need to be cooked, and I was amazed to see how they are passed through powerful steamers, where they are cooked for several minutes. This step is crucial for preserving the texture and flavor. After cooking, the noodles are fried in hot oil. Special machines equipped with high-temperature vats ensure even frying. This method gives the noodles their crispiness and makes them suitable for quick preparation. Now I know that there are more diet-friendly types of ramen, and the difference lies in this stage of production. To avoid adding oil, some noodles are dried using hot air instead. Specialized drying chambers circulate hot air to evaporate moisture. After drying, the noodles are ready for packaging. In instant ramen production, fully automated packaging lines are used. Personally, this is one of my favorite stages to watch during factory tours, aside from the tasting, of course. The machines cut or shape the noodles into compact blocks that fit neatly into the packaging. Each noodle block is placed in a waterproof bag or container. At the same time, packets of seasonings and flavorings are added to enhance the taste when prepared. Naturally, every package includes a small packet of concentrated spices and broth, either in powder or paste form. These may contain soy sauce, meat broth, dried vegetables, and various spices. This ensures that instant ramen has a rich, flavorful taste once water is added. Every stage of instant ramen production undergoes quality control to ensure a safe and consistent product. This process includes checking the quality of the noodles, moisture levels, and the weight of each block. Specialized detectors also scan for the presence of any foreign objects in the finished products. Once packaged, the instant ramen packs are placed into boxes and sent to storage facilities. The product has a long shelf life thanks to the dried or fried noodles and airtight packaging. Storage conditions must maintain low humidity and a stable temperature to preserve product quality. In the United States, instant ramen is incredibly popular. Every year, approximately 4 to 5 billion portions are consumed, placing the US in the top 10 countries by consumption volume. While the per capita consumption is much lower than in countries like South Korea, Japan, or China, Americans still enjoy this product for its convenience, quick preparation, and affordability. If you were to stretch the noodles from a single packet into one continuous line, It would measure about 3 yards, and I haven't been able to stop thinking about that for days. Guess what I'll be doing today? As for an invitation to eat ramen in Asian countries, it's their equivalent of asking someone to Netflix and chill after a date. Did you know that railroad tracks can actually bend like noodles? Yet in an instant, they become tougher than rock. Every year, over 15 million tons of steel are used to build these tracks. But how do we transform raw iron ore into rails that can withstand the weight of thousands of tons? Stick around to discover how cutting-edge technology and precision engineering are revolutionizing infrastructure. The process of manufacturing railroad tracks is a fascinating blend of advanced technology and heavy machinery. But it all begins with iron ore. This ore is mined either in open pits or underground. Open pit mining is used when deposits are near the surface, employing massive excavators and drilling machines. For deeper ore deposits, underground mines are excavated. Once the ore is extracted, it is crushed and refined through several stages to separate the iron and remove impurities. The enrichment process involves crushing, grinding, and either magnetic or flotation separation, which produces a concentrate with a high iron content. To create a strong and flexible alloy, carbon is added to the iron ore. This carbon typically comes from coking coal, which undergoes high-temperature processing. Other elements like chromium, manganese, nickel, or molybdenum are also added to the steel to enhance its strength and other critical properties. Every year, more than 15 million tons of steel are used worldwide for railway tracks. This represents a significant portion of global steel production, and demand continues to grow due to infrastructure expansion and the need to replace worn-out tracks. After extraction and initial processing, the raw materials are transported to steel mills. Rail and maritime transport are commonly used, especially for long distances, since ore is often mined in remote areas. Thus, steel production for rails involves combining various materials sourced from different parts of the world, with the extraction and processing stages relying on complex machinery and a multi-step refining process. The production of railway tracks begins in the steelmaking facility, where iron ore and other components are melted in specialized electric or blast furnaces to create molten steel. Carbon and alloying elements are then added to the steel to enhance its strength. Once the desired composition is achieved, the metal is maintained at a high temperature to ensure uniformity. The molten steel is poured into large molds, forming slabs, rectangular blocks of steel that will eventually be shaped into rails. After cooling, the slabs are transported to the rolling mill for further processing. A rolling mill is a massive machine that shapes steel slabs into the desired form and size for rails. The slabs pass through a series of rollers, which gradually reduce their thickness and form the railhead, web, and base. The rails are rolled at temperatures exceeding 1,832 degrees Fahrenheit, making the metal more pliable. To increase the hardness and wear resistance of the rails, a heat treatment process is applied. The rails pass through cooling chambers, where the temperature is gradually reduced, minimizing internal stress in the metal. Typically, 1 foot of rail weighs about 45 to 55 pounds, meaning a standard rail weighs approximately 3,858 pounds. A large steel mill can produce around 3,500 feet of rails per shift, roughly 10,000 feet per day. Once the rails are finished, they undergo thorough inspections for defects such as cracks, surface irregularities, or other damage. Specialized ultrasonic and X-ray techniques are used to ensure quality. After inspection, the rails are cut to standard lengths of approximately 1,000 inches, and their ends are machined for easier connection during installation. Once manufactured, the rails are transported to construction or repair sites. Trains specially designed for carrying long rails are typically used for this purpose. Freight cars secure the rails tightly to prevent any movement during transit. Laying railroad tracks is a complex process that requires the use of specialized machinery. First, the ballast, which serves as the foundation for the ties and rails, is leveled and compacted along the railway bed. This ballast is crucial for the stability of the tracks and for proper drainage. Ballast spreaders evenly distribute the crushed stone, creating a stable layer on which the ties and rails will be laid. Automatic tie laying machines then place wooden or concrete ties on the prepared ballast base, ensuring they are spaced precisely. These machines are equipped with sensors to maintain an exact distance between the ties, which is essential for the stability of the future track. Railroad rails can last up to 30 years or more, depending on the volume of traffic and environmental conditions. However, on high-traffic routes, such as those used for freight trains, rails may wear out more quickly and require replacement every 10 to 15 years. Next, the rail laying machines take over. And oh my goodness, what a mesmerizing sight it is. When we think of rails, we usually picture something as rigid as stone. Yet during the laying process, they seem to bend under the influence of the machines, almost like rubber bands. In reality, this is due to the immense forces acting on them. When rails are first rolled out, they're heated to extremely high temperatures to make the steel more malleable and easier to shape. During installation, rails are sometimes reheated to prevent future thermal expansion, which gives them that seemingly softer, more pliable appearance. Specialized machines carefully lift, align, and position these long sections of rail as though they're weightless and not the solid, unyielding steel we know them to be. It's all thanks to precise manipulation and the illusion of flexibility, which cleverly conceals the incredible strength of the steel. This is one of those fascinating railway magic tricks, where raw power and advanced technology combine to create a spectacle that's as captivating as it is impressive. Workers then join the rails using specialized bolted or welded joints. Thermite welding or electric welding equipment is employed to create a seamless rail line, ensuring a smooth ride for trains. It's remarkable how much effort goes into making it possible for me to visit my favorite grandma, or for any office worker to commute to their job. To secure the rails to the ties, special fasteners are used to clamp them firmly in place. This ensures stability and prevents the rails from shifting under the weight of passing trains. Rails have the ability to freely expand and contract by a few millimeters for every 10 yards, depending on the temperature. As a result, when laying tracks, engineers take average annual temperatures into account. In some cases, the rails are even heated to a specific temperature during installation to minimize the effects of thermal expansion. Automatic fastening machines quickly install bolts or clips to connect the rails to the ties, significantly speeding up the process. Once the rails and ties are in place, specialized machines align the track by lifting or lowering the ties and adjusting the ballast beneath them. Thanks to laser sensors and computer control, these machines ensure precise track alignment, which is critical for safety. Other machines tamp the ballast, crushed stone, around the ties, providing a solid foundation. This reduces the risk of track shifting and enhances its resistance to vibrations. These machines are equipped with special tamping arms that dig deep into the ballast and compact it firmly around the ties. Rails are often made using a significant percentage of recycled steel, as steel retains its properties well during reuse. This helps reduce the need for new ore extraction and lowers the carbon footprint, contributing to a more sustainable production process. Did you know that the world's largest mozzarella producer uses 5 million pounds of milk every day? This massive operation ensures that every drop of milk undergoes strict quality control. In this video, we reveal the secrets behind this enormous production process, where mozzarella is stretched to the perfect texture through machinery worth millions of dollars. Want to see how ordinary milk transforms into a true cheesy masterpiece? Don't miss a single second. Milk is the primary ingredient for producing mozzarella. Leprino Foods partners with local farmers and dairy cooperatives who supply fresh milk in optimal volumes. To ensure consistent quality, the company sources milk primarily from regions close to its production facilities. This minimizes transportation time and preserves the milk's freshness. Suppliers go through a rigorous selection and monitoring process, as every batch of milk must meet Leprino Foods quality standards. Each shipment is tested for contaminants, bacterial levels, and key factors like fat and protein content, which are essential for mozzarella production. Any milk that doesn't meet quality standards is rejected. Milk is delivered to the plant in large refrigerated tankers that keep it at low temperatures to maintain freshness. Once the tankers arrive, they connect to the milk intake system, which pumps the milk into large storage tanks. These cooled tanks hold the milk at around 39 degrees Fahrenheit to prevent spoilage until it's ready for pasteurization. Each tank, capable of holding thousands of gallons, is monitored by automatic temperature control systems. From these tanks, the milk is automatically transferred to pasteurization units, requiring no manual handling, as pumps and pipelines ensure its safe transport. At large production facilities, pasteurizers are directly linked to the storage tanks to minimize the risk of microbial contamination. Inside the pasteurization unit, the milk is heated for 15 seconds in a standard high-temperature, short-time pasteurization process. This takes place in a heat exchanger, where the milk flows through a series of tubes surrounded by hot water or steam. After this brief heating, the milk is quickly cooled back to its original temperature in the same heat exchanger. Here, hot milk encounters cold water without mixing, which helps retain its freshness and nutritional quality. A key step in mozzarella production is the coagulation process, or curdling of the milk, which creates the foundation for the cheese. To achieve this, milk is combined with rennet, an enzyme that helps form curds. Additionally, bacterial cultures may be added to promote milk acidification, laying the groundwork for the cheese's flavor profile. After pasteurization, the milk is automatically transferred to cheese-making vats, large stainless steel tanks with smooth interiors for easy cleaning and sterilization. Once the milk is in the vats, an automated system adds rennet and bacterial cultures. These vats are equipped with automatic mixers or paddles that gently and evenly distribute the enzyme through the milk. Temperature control systems maintain the milk at an ideal temperature to support proper coagulation. After adding the rennet, the mixing stops and the milk rests for 30 to 40 minutes. During this time, the enzyme converts the milk protein, casein, into a dense mass of curds, the cheese base. I have to say, the smell at this stage is quite unique. It's intensely sour, almost hard to believe this will eventually become something edible. But as the process continues, the appearance improves and the aroma turns more appetizing. The next step is whey separation. The cheese base is heated, which makes the curd denser and helps release the liquid faster. This whey is collected for further processing or repurposing into other dairy products. Now it's time to stretch the cheese. Yes, you heard that right. This is the key step in mozzarella production. At this stage, it actually has a rubbery texture. Traditionally, this stretching was done by hand, but at Leprino Foods, the process is fully mechanized. The cheese is placed in a specialized stretching machine, where it is continuously mixed and pulled by paddles or screw mechanisms that carefully stretch and fold it. The machine rotates slowly, giving the cheese a stretchy consistency without breaking down its structure. The screw mechanisms turn in different directions, which helps evenly distribute the proteins and gives the cheese a smooth texture. During the stretching process, cooled air is added to gradually stabilize the cheese and prevent overheating. This cooling step is also essential for achieving the perfect mozzarella texture. Stretching stops automatically when sensors indicate the right consistency. At this point, the cheese takes on an elastic structure and can be easily shaped into the desired form. Cheese can be shaped into various forms, like balls, blocks, and cubes on automated production lines. Let's look at the different processes. To make cheese balls, the cheese is fed into a specialized machine, where it is rolled between rotating discs or paddles that portion it into small sections and shape it into balls. The machine can adjust the size of the balls to create the desired dimensions, from tiny pearls to larger balls suitable for salads and appetizers. For larger cheese blocks, stretched cheese is placed in special rectangular molds. Within these molds, the cheese is compressed and then cooled to help it retain its shape. After cooling, the blocks are cut to specific sizes and packaged. To produce cheese cubes, the cheese is first formed into larger blocks, which are then sliced into small, uniform cubes by automated cutting machines. For stick or strip-shaped cheese, a large block is initially sliced into strips using specialized blades, after which the strips are packaged. These cheese sticks are convenient for snacks or appetizers. Next, we move on to salting mozzarella. This step impacts not only the flavor of the cheese, but also its texture and shelf life. First, a special brine solution is prepared. A concentrated mixture of water and salt at a specific concentration, maintained at a low temperature to prevent the cheese from softening. The solution is carefully stirred to ensure the salt dissolves evenly, creating a stable level of concentration. Depending on the shape, whether balls, blocks, or sticks, the cheese is transferred to the brining baths on a conveyor belt or in special containers. It is important for the cheese to be fully formed and stabilized before salting. Otherwise, it may lose its shape. The cheese is immersed in the brine solution in specialized brining tanks. These tanks may include a gentle mixing system to ensure that each piece of cheese is evenly coated by the solution. Salting takes between 15 and 30 minutes, depending on the size of the pieces, allowing the salt to penetrate the outer layers and give the cheese a mild, salty taste. Maintaining a consistent salt concentration and temperature in the bath is crucial to ensure quality salting. Automated control systems monitor the salt levels in the water and add salt as needed. Temperature is also regulated to prevent the cheese from softening or drying out excessively. Once the salting process is complete, the cheese is removed from the solution via conveyors and carefully dried. This is done on special racks that allow excess brine to drain off, or with gentle airflows that softly dry the surface of the cheese. After cooling and salting, the cheese is transferred to the packaging line on a conveyor belt. These may be mozzarella balls, cubes, sticks, or blocks, each moving toward different packaging stations based on their shape. Near the line, a machine supplies the packaging materials. These could be plastic bags, containers, or vacuum-sealed pouches. The machine automatically unwinds the packaging material, prepares it for filling, and ensures each package is clean. When the cheese reaches the packaging station, a specialized dispenser automatically places the correct amount of cheese into each package. The machine measures portions with high precision to ensure that all packages have the same weight and appearance. Once the cheese is in the bag or container, the packaging machine seals it. This might be vacuum sealing, where air is removed from the package for optimal storage, or heat sealing, where the top of the package is heated and tightly welded to create an airtight seal. After sealing, the packages pass through a special printer that automatically prints labels with product information, such as the production date, expiration date, and sometimes a barcode.